Thank you very much for the introduction, Meredith. Good morning, good afternoon, everyone. Thank you all for joining us today for today's seminar from IARPC's Monitoring, Observing, Modeling, and Prediction team, affectionately known as MOMP. My name is David Clemensoul. I study the Arctic at the National Oceanic and Atmospheric Administration's Physical Sciences Laboratory, and I co-lead the MOMP team with my colleagues David Allen at NOAA's Arctic Research Program, Dr. Sally McFarlane at the Department of Energy's Atmospheric Radiation Measurement Program, and Dr. Kiki Schultz at the University of Texas's Odin Institute. So a key goal of the MOMP team is to break down silos and foster communication that advances Arctic research. And for today's seminar, we are looking back at one of the seminal advances in Arctic research, which was the 1997-1998 surface heat budget of the Arctic Ocean, or SHEBA experiment. Dr. Don Perovich from Dartmouth College and Dr. Melinda Webster from the University of Washington have graciously agreed to present on the history of SHEBA and its connections to recent and future Arctic research. So the two of them will present first, and then after their presentations, we're going to have a discussion about SHEBA's legacy and about how knowledge gained from SHEBA can continue to support understanding of the Arctic. So two quick logistical notes before we get started. First, please hold verbal questions for the discussion. So we won't have a break for questions between Don and Melinda's talk. You are welcome to write questions in the chat, which we'll get to in the discussion. And then additionally, as Meredith said, in the interest of time, we're not going to be able to start this with a round the room introduction. But the first time you pipe up to speak in the discussion, please introduce yourself. And then finally, we will have 5 minutes at the end of the seminar for general updates. So with that, Don, please take us away.
Well, thanks for the opportunity to talk about one of my most favorite things to talk about, SHEBA, the surface heat budget of the Arctic Ocean. SHEBA is a major climate change initiative sponsored by the National Science Foundation and the Office of Naval Research. And SHEBA was big. There are over 200 researchers involved from about 25 different institutions. And SHEBA had 3 phases. Phase 1 was going from an idea to a program. The planning started in 1990 and extended all the way till 1997. During that time, we had 8 meetings and produced 7 different documents. It took a lot of time. To put that in perspective, that's how my kids grew up while I was helping to plan SHEBA. And I bring this up because the next IPY is in 2032, 7 years from now. And it's really not too early to start planning. And it was useful for us to have this time because SHEBA was a complex project that really took a lot of time to figure out what we wanted to do and how we wanted to do it. We came up with 2 overarching goals: determine the ice-ocean atmosphere processes that control the ice albedo feedback and the cloud radiation feedback, and then develop models and improve simulation of present-day climates and simulations of future climates. We wanted to understand the feedbacks and then use that understanding to improve models. So how are we going to do it? It took a lot of time to come up with an approach. And we decided that approach really had to integrate the atmosphere, the ice, and the ocean, and combine observations with models. And we decided to have an interdisciplinary approach rather than a multidisciplinary approach. And this is more than just subtle semantics, because at that time, most of us have been involved in many multidisciplinary experiments where you had a group of people from diverse disciplines at the same ice camp on the same ship, kind of doing their own thing. But SHEBA was different. The atmosphere, the ice, and the ocean teams were all working towards those common goals. And that led us to phase 2. Ice Station SHEBA, the year-long drift of the Canadian Coast Guard icebreaker de Grossier. On October 2nd, 1997, it was frozen into the ice and drifted for just a little over a year until October 11th, 1998, drifting over 2,800 kilometers for a displacement of 800 kilometers. And you can see the drift track, here. A year on the ice, it was just an incredible opportunity to be on an ice floe and see how that flow changed over time, from fall freeze up through winter into spring into summer. We got to watch ice dynamics in the winter in February, getting a reminder that there was an ocean under this ice camp as leads open up straight through camp. And in March, learning what breaks apart and come back together as ridging disrupted a lot of activities. And in the summer, we got to watch the melt ponds bloom like so many flowers. We got to really see what was happening. In our central effort was on the SHEBA column, this imaginary cylinder that went from the top of the atmosphere through the clouds to the surface, through the snow, the ice, and into the upper ocean. And we wanted to measure everything about this column every day for a year. We wanted to measure shortwave and longwave radiation, cloud properties, air temperature, humidity, wind speed, the turbulent fluxes. We wanted to look at solar partitioning and the ice mass balance and internal ice stresses and snow and ice morphology and the ocean momentum and heat flux. And we assembled a wide array of instrumentation to do that. Here are some of the instruments to get an idea of what sorts of things we were measuring and how we did it. There was the 20-meter Met Tower, which was really a symbol of SHEBA. And on that tower at different levels, there are sensors measuring air temperature, humidity, and wind speed to get information on the turbulent fluxes. There are twice-a-day balloon launches looking at profiles in the atmosphere. The ship was the base for an array of shortwave and longwave radiation sensors as part of the ARM mobile site. And there are cloud radars and LIDARs looking at cloud properties. And there were lots of measurements made on the ice. We had extensive albedo measurements, both of broadband and spectral albedos, looking at the variation of albedo over space and over time. And mass balance was measured at over 120 different sites, so we could see the snow build up during the winter and the ice grow, and then in summer, how the snow melted and how there was surface melting and bottom melting. And in the ocean, there was an ocean mast, which was the flip side of the Met Tower, measuring profiles of temperature, salinity, and currents. And there are other instruments looking at ocean momentum and heat flux, measuring everything every day for a year. And while this was our central focus, it wasn't our only focus. We also wanted to be able to scale things up, to look at the aggregate scale, the scale of a grid cell. And that was done through a number of ways, including aircraft measurements of the atmosphere. There were also helicopter photography surveys and also satellite photographs, so we could get an idea of how the SHEBA flow fit into the larger area to scale up to a grid cell. So that was SHEBA phase 2. Phase 3 was after the field campaign. It was analysis, synthesis, and modeling. It involved a lot of collaboration, integrating our data sets, figuring out how to scale up these observations, all with the idea of understanding the ice albedo and the cloud radiation feedbacks, and then using that understanding to large-scale models. We needed to synthesize the results on a number of different scales. And there were a lot of publications that came out of SHEBA. In 2002, there was a special issue in JGR Oceans that had 22 SHEBA papers, and these papers took an excellent look at various components of SHEBA. Tennille did a survey and found over 670 publications that referenced SHEBA in some way. The synthesis that I've talked about throughout happened gradually. In fact, during SHEBA, there was phase 3, the SHEBA Interdisciplinary Prize was announced. And what it was whoever came out with the first paper that integrated atmosphere, ice, and ocean observations to learn something new won a pound bag of every kind of M&Ms that were available. And Ola got that prize in 2016. So doing this integration takes a while. The publications are still coming. My last SHEBA paper was in 2021. And most importantly, the data set is widely used. It's still widely used even today. And if you want to get a sense of an overall look at SHEBA and what kind of data are available, I'd like to refer you to a paper that Tennille did back in BAMS in 2002. It's really an excellent summary of what happened at SHEBA, and it's a good entryway into getting a sense of the data. And from the very beginning of SHEBA, our saying was the data are the legacy. That years and even decades after we're done with this, people will be still using the data. And it turned out that seems to be true. The SHEBA data now are all archived at the Arctic Data Center. If you go to that site and you search on SHEBA, you'll get a long list of SHEBA data with associated metadata. It's really a great resource. And I do want to comment that at the time during the planning of SHEBA, we were told that all of our data needed to be formally archived within a year of the end of the field campaign. And nowadays that seems like, of course, that's what you would do. At the time, it was pretty novel, and there was some pushback saying, well, if I archive my data, then anybody can use it. Well, that was the point. And I think with this data archive, it's been available for people to use afterwards, and it's all there and you can use it. Of course, there's data, and then there's gray data, the things that may not have made it to the archive. There's field notebooks. Now, a lot of what's in the field notebooks made it into the formal data archive, but maybe not all of it. And then I think most of us kept some sort of daily log that talked about what measurements we were making and that Monday was grilled cheese day on the ship. And I'm not sure if those logs have made it in. And I think various groups also came up with their own little format to summarize their data. In the case of the snow and ice group, we came out with a CD that had a website with all of our results. Now, the results are all in the archive, but what this also has is a lot of photographs and a lot more explanation of what we did and how we did it. And it does have everybody's daily logs. And at the time, I passed out over 600 of these, but I don't think it's at the archive. And then there's SHEBA ephemera, or maybe SHEBA detritus, depending on how you look at it. And at the bottom there is a picture of my bottom shelf of one of my bookshelves, and that's all SHEBA results. It includes things like the weekly situation reports and some email traffic that went back and forth from the ship to the shore. It also kind of has some data that were things that you measured, just you had some time one afternoon, so you went to a melt pond and measured some temperature and salinities. It was, but it didn't really amount enough to write a paper about or to archive. And in this case, there's a lot of photographs. There's over 1,000 photographs. And in 97 and 98, digital cameras weren't very good. And I think most people took their photographs using film. And these photos can be archived, but they would first have to be, digitized. So just to wrap things up, a few special things about SHEBA. There was lots of planning. It was a year-long drift, and those opportunities really don't happen very often. It was an interdisciplinary program, but it's important to mention it did have a multidisciplinary element, and there was a lot of excellent ecosystems work that was done during SHEBA that wasn't oriented towards those SHEBA goals. I think in some ways, most importantly, there's archiving of all the data. SHEBA had major outreach. There was a lot of media. We had the New York Times, the Washington Post, Scientific American, Good Morning America, the CBS Evening News, and other media folks come up to SHEBA. There was also a lot of K through 12 outreach. In fact, SHEBA became the template for a year's competition of the first Lego League, where they tried to do things that we did on SHEBA. And for me, a big part of it was all the people involved. It was an opportunity to spend some time with a really great group of people and learn a lot of things as well. Thank you.
Thank you very much, Don. It's a wonderful presentation. So as a reminder, please hold your verbal questions to the end. You're welcome to write questions in the chat that we will come back to in the discussion. Next up, we have Melinda Webster, who's going to present on the SHEBA legacy and expeditions, past, present, and future.
Great. Thank you, David. And thank you so much for this opportunity to discuss what's been done in the past and how some of those ideas and lessons learned can help shape what we do for this upcoming IPY in 2032. So let's look back a little bit further from well before SHEBA, but thinking about what's motivated observations and more importantly, what's motivated sharing those observations. And at the beginning, and this is from a Western science perspective, at the beginning, this was really about avoiding hazards and knowing what was there. And this is during the age of exploration and whaling and really mapping out where sea ice is in the Arctic and what the weather was like in the Arctic and the Antarctic. But it was this information that was primarily used and shared to know how to avoid problems while navigating in these extreme environments. And I will say that data legacy wasn't really thought of at this time, and the legacy that's come from these observations have been largely due to data rescue efforts. And I think that's an important topic going into IPY, knowing what's there and what can be rescued to establish these valuable records or retain these valuable records. With the first IPY in 1882, this was a major change in how observations were collected, and this was primarily for understanding what the weather was like, to really understand how to safely and have these capabilities of navigating in these extreme environments. And there were also geophysical observations established as well. Now, again, data legacy was not such a big topic of thought when collecting these data, and it's really an aftermath of people like Kevin Woods and Jim Overland and several folks at the National Snow and Ice Data Center to collect and compile observations such as these to create valuable observational records. Now, with improving technical or technological capabilities, we're able to get more valuable information about what the climate state was like in polar regions. And with this, we had more detailed information about what was happening in the atmosphere, the sea ice, and the ocean. And again, largely due to these data rescue efforts, like with folks like Lawrence Federer, who I saw was on the call, and several others at NSADC, a lot of this information has been preserved and quite valuable. Now, there was a transition in collecting and sharing observations, and that was really to improve our capabilities of being in the Arctic. And a big part of that was understanding what the winter period was like. This was a massive knowledge gap. And so, with the establishment of the first drifting ice stations, there was a lot of valuable information collected from the meteorological side, oceanographic side, and sea ice. But you might think this is a little interdisciplinary, but it was very multidisciplinary. There wasn't much in the way of connecting these different disciplines and the knowledge gained of those different disciplines together. So in that sense, we still hadn't reached yet the interdisciplinary nature of climate science and data legacy. With the International Geophysical Year in 1957, we had many more drifting ice stations, and we also had unstaffed drifting ice stations. So these were through autonomous platforms that really helped piece together what weather and climate was like in the Arctic. And I would say that these things listed here, this has been really valuable in the efforts that people have gone to preserving that data and preserving those logs. But there's still a question of the gray data that Don alluded to. Is that useful? Can it be informative for people doing science now and in the future? Okay, so moving forward in time, we've had a lot more establishments of more routine and standardized observations. And this has been tremendous from a data legacy standpoint. And being able to look at a history of what air temperature has been doing, what sea level pressure patterns have been doing in the Arctic, and understanding both natural climate variability and climate change. A lot of these efforts have been accomplished because of data rescue, but it's also been a lot of I say, working with many groups to declassify valuable data. So for instance, the SciSec Science Advisory Committee and the Arctic Submarine Laboratory and NSIDC have done a really nice job in, I would say, elevating the scientific value of these data and making it publicly available to people to understand, for instance, how Arctic sea ice thickness has changed over the decades. Now, it really wasn't until SHEBA that data were being collected with a purpose for data legacy, and to have this vision of the data having tremendous value decades after the fact. And Don nicely covered this in his presentation, so I won't go into it. But I will say that there's been a lot built on the shoulders of these giants from SHEBA in terms of data value and legacy. And it's kind of like if you're a musician and learning to play a song on an instrument, you get better with practice each time that you practice. And that's been the case for many of these drift experiments over time, especially if they've moved forward to really connecting these disciplines together to give a more holistic understanding of climate science in the Arctic. But moving forward, I want to focus and highlight what's been accomplished with a more recent drift experiment, the MOSAiC campaign. And I know there's many MOSAiC people here, so I'm hoping you'll chime in the discussion later. But for those of you who may not know about MOSAiC, it was a year-long drift experiment in the Central Arctic. And MOSAiC stands for the Multidisciplinary Drifting Observatory for the Study of Arctic Climate. This was largely motivated by the need to fill the critical knowledge gaps that we're missing in being able to project what's going to happen in the future. And we have a lot of knowledge gaps about the different components of the Earth system in the Arctic. So we had many years in advance for planning what sorts of processes we needed to target with measurements. There were measurements in the atmosphere component, the ocean component, the sea ice in between, and the ecosystem. So even though this seems quite multidisciplinary, it was also truly interdisciplinary. There was a lot of interaction between coordinating these different measurement plans. Now, I mentioned before, this is strongly motivated by the fact that some of the largest uncertainties in climate model projections is occurring in the Arctic, in these polar latitudes. And this is especially the case because we don't have a lot of information about what physical processes and interactions are occurring in the winter month when it's really hard to get out into the Arctic just because the ice is thick and it's a very extreme time of year to be there. Now, I also mentioned that this is multidisciplinary and interdisciplinary, but it also had a lot of value in bringing models and observations together in a scalability sense. So there was a lot of remote sensing efforts done in validating what capabilities and what products existed from remote sensing assets, but also being able to scale up what was measured on the ground to the satellite footprint, which can be more readily comparable to climate model output and process model output. So this wasn't just developed on the fly. I think the planning for MOSAiC took at least 10 years, and I see Matt Schuss on the call. Maybe he can allude to this or enlighten us about this in the discussion. But there was a lot of pre-planning that went into this to fit all these different complex components together for this field campaign. Now, I said it was large. It was the largest Arctic expedition in history. There were more than 500 scientists involved, more than 80 institutions, and from those 80 institutions, 37 nationalities. And you can't help but wonder, where do you begin with data legacy for something that is so large and complex? But coming back to this planning, there was a massive data component, both planning before, during, and after the field campaign of MOSAiC. And a lot of this was done in parallel with developing a measurement protocol. I think that went a long way in envisioning what the data would look like and how we would deal with that data after the fact. So we had planning meetings both virtually and in person. And I think having the combination of both really helped make this a success story in terms of data legacy. Now, for participants coming from all these different institutions, every single person signed an agreement that raw data that was collected during the campaign would be made publicly available 3 years after the cruise. So in January 1st, 2023, all the data were available. I also appreciate that with all of this planning and the recurring discussions about data before, during, and after the field campaign, it really helped create this data preservation culture and made it a much more normalized thing. And I think that went a long way in helping lighten the load and making it a cultural norm in our bubble of our MOSAiC community. And they also helped lighten the load by giving different people leadership roles for these different measurement suites. So for example, there are disciplinary teams like a atmospheric team or a sea ice team, but within that team, there are many tasks that were being done, and the leader of those tasks would work with their group to make sure that the measurement protocols were followed and that the data were archived. Okay, so while we were in the field, this was a new experience for me, but I think it made a big difference is that we had this ship central data storage. So while we're in the field and taking all these measurements, we could log the data into the ship storage system so that all the raw data would be preserved. There would be no risk of losing this valuable data that's being coordinated across all these different institutions. So to do this, we actually had training sessions to understand how the data system worked, how to log our instrument information in before the field campaign, and also how to log the data while we're in the field. There was data support on the ship for each leg of the cruise. I would say that this is a pretty game-changing way to think about data and to deal with data while in the field. It did take a little bit of time and a bit of a learning curve. But on the flip side, the data days were our rest days from being out on the ice. So, it can be good and bad, but it really did force me to think about data in a different way, and I think several others as well. Now, what the shipboard system didn't do was it didn't capture that gray data that Dawn was describing. So we have a lot of notes and photographs, field logs, and diaries. Like, what do you do with that? Is that of value? And I would say it's of tremendous value because it can really help understand some of the data caveats, like why an ice thickness measurement wasn't taken in a particular spot because there was a hole there. Like, how do you express that information in data? It's not always included in metadata. It also has a tremendous value in insights of knowing how to deal with challenges and how to operate in the field. Like, what is the value of these pictures from the North Pole Drifting Ice Station and from Ajax? And I would say it gives insight on how to deal with those challenges in the field just by looking at something like that or speaking with somebody who's had that experience. Okay, after the field component, all projects had some form of data archiving and curation. And we did a tremendous job in staying connected with each other in our different projects across these different nations through online meetings and in-person meetings, and that really helped move things forward and helped spurred further collaborations. But I also noticed that a lot of the data curation fell on early career researchers to lead, which is a really awesome opportunity for a leadership role, but I saw some successes and some challenges with that. The success stories were where early career researchers and PIs worked closely together to quality check and process the data and to archive the data together. And this not only provided scientific collaboration, it also provided a two-way street for mentorship, which I think is so valuable. For instance, the early career researchers learning about open science policies, and a PI can learn about all these new tools that enable open science. The challenging stories that I saw were the early career researchers who were left to do the data processing and archiving on their own. And especially if it was a complex data set, this could be really hard and it can take a lot of time and detract or take away time from the science. And when you're trying to retain early career researchers in the field and really build up their expertise in science, I think that can be a really important takeaway that maybe we can do something a little different in the future for different field campaigns. We also learned that data synthesis efforts, so major merging of different data sets, could be a project in itself. And this takes a lot more time than often what a field campaign proposal can entail. So this is another lesson learned that I hope can help frame how things are done in the future. And then, of course, there were different expectations on where data could be archived, depending on the funding agency. And if you want to see a really nice example of bookkeeping of that, you can go to this website and check it out. So, okay, thinking about IPY, even though it's in 2032, it's actually not that far away for planning. Here are some of the data reflections that I'll go through quickly that I think can be some helpful discussion points. And that's thinking about how data archiving can be a leadership opportunity and career development opportunity if there's mentorship and collaboration involved, and also time for science. In terms of data legacy, the planning for that starts now. There's a lot of things that we can work out through these discussions, whether it's measurement protocols or data management strategies and understanding differences across nations and their agency expectations. There's also time to think about and brainstorm, well, what can we do to ensure that these major data synthesis efforts have the time and support to really accomplish their goals? And then lastly, thinking about gray data, it would be really helpful, I think, to survey what value there is in the available gray data sets from SHEBA, from MOSAiC, and other field campaigns, and identify whether or not there are data rescue opportunities there. It takes a lot of time to archive data, but there's a lot of value in that data. It can be a gold mine of information. With that, I'll stop. Thank you.
Well, thank you very much, Melinda. Thank you, Melinda and Don. Those are both wonderful presentations. Um, so we now have plenty of time for discussion, both on the presentations and on the SHEBA legacy in general. And to help structure this discussion, the MOMP team came up with a couple of sort of key questions that we thought would be helpful for folks to discuss. So I think everyone also, is my screen sharing? Can't quite tell.
It's trying.
Nope. Okay. Well, even in 2025, Zoom is still a struggle. So I'll go ahead and I'll read out the questions, and I can enter them in the chat as well. So the three questions we wanted. Oh, go ahead, Don.
I was going to say, it was saying double click for full screen, so I don't know if you needed to double click.
I don't know. I'll just read them out and put them in the chat. So the three questions we wanted to touch on in the discussion, which I think our presentations also really nicely touched on, are first, what did we learn from SHEBA that still guides our understanding of the Arctic system today? And second, what do we fear that we are forgetting or losing from SHEBA? So especially things like the gray data that Don and Melinda both mentioned strikes me here. And finally, thinking about, are there new analyses of SHEBA that could further our understanding? And also thinking about SHEBA in the context of MOSAiC and IPY, are there analyses we should be thinking of doing and thinking of including SHEBA data? So I'll go ahead and put those in the chat. And while I'm doing that, if anyone has any comments or questions to start us off, please just unmute yourself, introduce yourself, and go ahead. I see that David's hand is up. Yeah, go ahead, David.
Yeah, so this more aligns with another activity that I'm involved with, but I'm very curious. I keyed into your comment, Melinda, during your presentation about the ship data storage and handling capabilities, and wondered whether that is something that is normally built, that was already built into the Polar Stern, or whether it was something that was added to the Polar Stern as a capability to support the expedition. I think you're probably aware that there are multiple efforts right now thinking about capabilities for future ice breaking vessels for the United States. but I think there's also similar efforts in Germany and beyond to also scope out the capabilities on icebreakers. I just wanted to hear your thoughts on that. Thanks.
Thanks, David. I'm actually going to pass that on to the AVI folks here, or the AVI Emeritus folks here, who might be able to speak more to that. Was that designed for MOSAiC, or did it already exist? I see Christian and Kiki.
Yeah, I can start. Christian can chip in. I think some systems were already installed, like DShip, that's a logging system, and data flows, for example, for the CTD data, like standard stuff that was already in place. But then there were some things that were specifically developed for MOSAiC, like sensor web, where you basically bookkeep all your instruments and sensors. And then the storage system where you could upload your data, that was also MOSAiC specific. And Christian, can you add?
Yeah, I mean, I would say from the AVI perspective, MOSAiC was a key chance to extend our system. So like the sensor web actually started about 5 years before MOSAiC with a project called FRAM, which was in Arctic observing infrastructure. But all those platforms really grew with MOSAiC, and also things like the flow navigation system and all the data logging stuff that has really been extended. But most of those features now are a standard part on Polarstern. So it's kind of, it has been a good program to develop the internal capabilities of Polarstern, to put it that way.
Lars, I see you have your hand up. Go ahead, please.
Yeah, thank you. I mean, it's easy for me to answer the first question. Yeah, I think, SHEBA is instrumental in, I teach most of the sea ice physics I teach here in Bergen is based on SHEBA, and it's in the sea ice book, right? But my big question is whether we need another drift campaign and so many people on the ice when there's so much development on the buoys, and that now you can get very cheap buoys and you can pepper the Arctic with thermistor chains, and so and also I was a bit concerned with the CO2 release from the last expedition. So I think that there's a lot that we can do with satellites and drift buoys, and do we need another big CO2 emitting field campaign, or can we do most important things with the drifters and satellite data? I think that's that's one of the big questions I'd like to raise, actually. Thank you.
Yeah, thank you for the question. I think it's a really good one. I have my own thoughts on it, but I thought maybe before I share those, are there other people? I'm thinking particularly people who have worked a lot with the buoy data. Might have comments and thoughts about what are some of the opportunities and also some of the limitations that necessitate having personnel in the field. I see both Ignatius and Ulla have hands up. I guess I saw Ulla's first. So go ahead, Ulla.
Okay, sorry, Ignatius.
No worries.
So as far as being out in the field, so I actually even got started in the LEADX field program a few years before SHEBA. And we had, in all the field programs I've been involved in, we've had some remote stations and some that were right near whatever ship we were on. But in every single field program, pretty much, the remote stations had some maintenance issues, whether it was they were damaged by bears or ridging or something like that. And so in order to maintain them, you really have to be there locally and to be able to access them at least within a few days or something like that. While you can get the data, you can see that, oops, something's going wrong here. In order to fix that, whatever's going wrong, then you've got to go out and address that. even our Met Tower at SHEBA, that was, we had data being collected there at a little hut at the base of the Met Tower, and that worked fine. But what we did every day, at least, if we tried to do every day, and at least ended up every other day or so, is we would walk the data on a CD, copied from those computers in that hut, over to the ship where we had other computers set up, and we would archive for ourselves. There wasn't a whole SHEBA archive set up on board the ship, but there were each individual group had their own way of archiving the data, typically on board the ship. And so it wasn't as extensive as on MOSAiC, certainly, and as complete, but it was still useful to do that. And that saved data from being destroyed by, like those pictures that Melinda showed, where huts were perched on top of snow pillars or ice pillars. So my own view is that while we can do a lot of things with remote buoy sites, and that technology has certainly come a long way, there are some practical things regarding maintenance that we still have to really be out there if we want to get a good, complete data set. And that'll vary from what the type of data set you're looking at. I imagine buoys hanging down further down in the water column, they may last longer. Certainly, I know some of the drifting buoys around the Arctic Ocean, they're lasting years now, some of them at least. But if you try to put something on the surface, that often disappears pretty quickly because of the very dynamic nature of the ice surface. So anyways, that's my comment on it, and I'd be happy to answer any questions regarding all that. But go ahead, Ignatius.
Yeah, as many of you guys know, I love buoys, and I pepper the Arctic with lots of these. These range in size from little baseball-sized things that are cheap and easy to make to like the ice-tethered profilers, which are who knows how much those things weigh, and you need an A-frame to deploy them. But I would argue that although I love the buoy program, it's not everything. And like your tool chest in your garage, you need screwdrivers, hammers, and bigger, more expensive things. And I think SHEBA, MOSAiC, all these big programs are wonderful. And it's, we can't do it all the time, but I think, doing a big field program in, for the IPYs, come 2032 or whatever it is, we just have more questions, and you're not going to be able to answer all those questions with a buoy.
Yeah, thanks. Thank you, Ignatius and Ulla. And I just want to point out to people that Kiki Schultz has also put a comment related to this in the chat. And I think this discussion aligns with my sort of personal view on it, which is that we should do a better job of making complementary autonomous and in-person and remote sensing measurements in the field. But there's some things that we still need people in the field to measure. I'd also like to highlight from MOSAiC, there was a group, I think I saw Amy McFarlane on the call here, focused on quantifying and reducing the environmental impact of in situ fieldwork as well. So I don't think that I don't think it's a question between, do we have a field campaign or not a field campaign? I think there are different ways for these field campaigns to mitigate their impacts. I see Aaron Davis has your hand up. Please go ahead, please.
Yes, can you hear me?
Yes.
I'd like to ask about the global thermal control system and the role of the Arctic winter in rejecting waste heat from the planet through open water like polynyas and leads. Because I noticed that it's obvious that you have 0 degrees centigrade or Fahrenheit water very close to the thinnest, coldest atmosphere on the planet, and it would be a great way to move, entropic currents into the Arctic to enact, to implement a thermal control system for the planet, which is something that I've always imagined would be a useful device or many devices. But I understand that I'm not, I did a doctorate in electrical engineering and a master's in geophysics, but I am not the expert, and I'd like to know about that. That's why I'm here today, and I'll leave it at that. If you have any questions, I'll turn my mic back on.
Yeah, thank you for the question. I'm certainly not the expert here, but I think the study of atmospheric and oceanic heat transport between the lower latitudes and the polar regions is a critical topic that more research could help support. Does anyone else have comments on that they'd like to share? Okay, that might be a topic for a future IARPC seminar of some kind. Oh, Ula, I see you have your hand up. Go ahead.
Yeah, I mean, broadly speaking, I think what you're talking about, Aaron, is both the transport to and from the Arctic regions in the atmosphere and in the ocean, as well as the surface energy budget or processes in the Arctic, especially during the wintertime you're talking about. And all of those were measured to one degree or another during both SHEBA and MOSAiC. And there's a few papers out on the especially surface energy budget at SHEBA, as well as there's now also starting to be some from the MOSAiC field program. And this idea about the energy fluxes in the atmosphere to and from the Arctic, in particular to the Arctic, is kind of the topic of a number of papers or studies going on right now for MOSAiC, for instance. So I agree totally with you that those are critical questions. That broad idea of how is the Earth losing energy to space during the Arctic winter, and there's a number of processes involved, and there's obviously a lot of key questions of how that really works, but there are some measurements along those lines and studies.
Thanks, Ola. Yeah, it's a much more complete answer than what I had. I'd like to ask a question of sort of the SHEBA generation here, which is, I thought it was really interesting in Don's talk, this focus on ice, ocean, atmosphere, column measurements, combined with the observation that the first paper that integrated all of them was in 2016, if I have that right. And maybe to put you all on the spot a little bit, why the 18-year gap? What was the what are the things that caused that gap, and what are things from that experience that we could learn from future for future research?
Well, I guess I'll start on that. And I think it's, to some extent, the challenge was a little bit of a wrinkle on things, because our goals were the feedbacks and then translating that understanding to models. And it wasn't necessarily making sure we touched all three bases in an integrated fashion. So I think looking at the timeline, we got back from the field experiment in October '98, and the clock started ticking to get the data in. And I'm not sure anybody really understood how big a pile a year's worth of data would be. And it was a surprise to me. And I think it was a lot of hard work to get that just in a state where it could be archived. And then I think, and we really had, I think, some generous funding and support for SHEBA. We had a 2-year planning stage, 3-year field experiment, and then 3 years for phase 3. But when we got to phase 3, I think for a lot of us, it was just trying to figure out what we had. And if you look at the 2002 special issue, there's papers on the albedo, papers on the surface heat flux, papers on ocean fluxes. So you see some really good work from disciplines. And then as time went on, there started to be some cross integration connecting the looking at the surface heat budget, which was the title, and then finally bringing in the ocean. So I think we were working on it, just really took a while to check that box. And that's why there were so many different kinds of M&Ms, not just plain and peanut, but almond and peanut butter, and it could go on and on. So I think that the synthesis did happen, and I don't know, I have to admit that sitting in meetings like AGU years later, when somebody puts up their model results and talks about how they use SHEBA data to help develop it, I smile, because I think that's, the data are the legacy, and I think that part has worked out really well. It'll be interesting to, I think these experiments all build upon each other. I know SHEBA, we build upon some of the lessons learned from AJAX and from IGY in 1957. And I think MOSAiC built on some of the things from SHEBA as well. So it's a relay race.
Yeah, thanks, Don. And I also want to highlight, there's a comment from Matt Shoup in the chat about how the sort of interdisciplinary work from MOSAiC has progressed at a more rapid timeline. So I think that also goes to your point about things building on each other. We are almost at the end of the hour. And we want to hold a minute or two for any more general updates. But before we do that, I do want to say that we on the IARPC MOMP team are envisioning this as the first seminar in a series about how we can work on continuing to transfer knowledge from the SHEBA and more recent experiments going into future experiments. So if this discussion has spurred any thoughts for you on what might be good future seminar topics or something you want to share in the future, please don't hesitate to reach out to us. And there's maybe some of you that will be getting reached out to from us regardless. And so with that, I want to preserve some time for are there other updates from any of the other team members want to share, and if anyone has any final comments about the SHEBA Legacy Seminar, you're welcome to say that as well. So go ahead. Yeah, Ula, I see your hands up. Go ahead.
Yeah, just briefly, I just want to reiterate basically what Don said too. The data is the legacy from SHEBA, and there's still a lot of analysis that can and I think should be done with that data set. And in fact, there's even some maybe considered to be gray data that never made it into the archives from instruments that officially weren't there, but actually were, like STODARs. There is plenty of analysis still to be done on the SHEBA data set, and it really I really think there should be a comparison between MOSAiC data and SHEBA data, or analysis of each of those, and seeing how the Arctic has changed, or can we really say that from those 2 points in different locations, 20 years apart? But potential is there for saying something about that at least.
Yeah, thanks, Ola. And I'll highlight there's a couple of papers that have, I am aware of a couple of papers. I'm sure there are many more that have started looking at that. I guess the one that comes to mind is one by Ian Raphael comparing the ice mass balance between the two. Carl Neuer, go ahead, please.
Yeah, thanks. There was an earlier question about autonomous versus in-person measurements, made from a drifting station, which does release a lot of CO2. But I'd like to say from experience, I'm of the generation of Matt Shoup and Bonnie Light, who were just finishing graduate school and were able to participate in the field, the phase 2 part of SHEBA. And that was a great career launching point. And just being able to interact in person with all these senior scientists, I think, carried a lot of value that can't be replicated with autonomous measurements.
Yeah, thank you, Carl. I think that's a fantastic point. I see Matt has his hand up as well.
I'll just make one point that relates to a few things that have been said. One is that MOSAiC took a long time to plan, and it was purely, it was totally on the back of SHEBA. I started thinking about MOSAiC in 2008, and the first person externally that I talked with about it was Don Perovich at a meeting in 2009 in Boulder. How do you do something like this? And then it took a decade to manifest. So it's really this kind of building process that's really important, and it does take a lot of time and a lot of effort. So I think that certainly the legacy of SHEBA is very well seen in MOSAiC and beyond, and I think that there are many steps to go in the future. And to Carl's point, it really, I was actually an undergrad at the time. I just had graduated undergrad even at SHEBA, and so it really launched my career, and I think it launched many people's career, and I hope MOSAiC did the same.
Yeah, I can second that MOSAiC did the same. Looking around at some of the names on this call. So with that, thank you all very much for joining. I want to thank again Don Perovich and Linda Webster for starting us off here. And this is an ongoing conversation we'd like to have within IARPC and within the MOMP team. So please don't hesitate to reach out. And with that, I'd say thanks for all of your time. Meredith, I'm going to stay on for a minute to try to read through all of these chat messages that I lost track of. So please don't close the Zoom call right away. Thanks.
Thanks, everyone.
Bye, thanks.